Hello friends, welcome to another video on BEE, and this question is asked in December 2009 paper, and the question says find the Norton equivalent circuit for a active linear network shown. So we need to find the Norton equivalent circuit for the network shown in a figure. So the question is, what is Norton equivalent circuit? Okay, so it is a reduction of any complex circuit that is here. For example, this is a complex circuit given to us, and it is a reduction of that circuit in a only two component. Okay, it's consist only two component, and that is a short circuit current ISC, and that is parallel to the total resistance RTH of the circuit. So this is our Norton equivalent circuit. So let's see how it's look. So I need to reduce this given circuit to a Norton equivalent circuit, and the circuit should look like this. Okay, so it should consist a current short circuit current source and total resistance, okay, across the given point, that is AB. So this is my point across which I want to find the short circuit current source, that is ISC, and the total resistance, that is RTH. Okay, so I want to find this two value to construct a Norton equivalent circuit from this given circuit. Okay, so the first thing we will find, that is RTH, because it is easy to find RTH. Okay, that is total resistance, and to find RTH we need to follow some rules, and that is this rules that we have to, the first thing we to find the total resistance of a circuit, we have to put all the values uh, in our circuit in the form of resistance. So I will put my own 15, 6, 10 and 4 ohm resistance, and I will try to eliminate this battery and also this current source. Okay, and how should I do this? By using this rules, that is, we have to short circuit our voltage source. So this voltage source here over here, sorry, this voltage source over here, so we need to short circuit this voltage source, and we need to open circuit, our current source. Okay, so you can see in this figure that our current source is open circuited. Okay, and our voltage source is short circuited over here. So after doing this, we will only remain with the resistance value of the circuit, and our circuit will look like this. So this is our circuit after eliminating the current source and the voltage source. Okay, so now we have to find the RTH value. we it's Okay, so we have to find our RTH value. Okay, and we will try to reduce this circuit in a one single resistance. Okay, and I will take the parallel combination of these two circuit to merge into one circuit, one resistance. Okay, so I will write 15 parallel with 10 ohms gives me, if you calculate this will come out to be 6 ohms. Okay, so the combination of these two resistance is 6 ohms, and you can see that this 6 ohms is over here. Now all I remain with the resistance which is in series. Okay, so all this resistance is in series. So I will, to find RTH, I will just do the addition, that is RTH is equals to 6 ohms plus 6 ohms plus 4 ohm, which gives me RTH value, that is 16 ohms. So my RTH value is 16 ohms. Okay, so this is my RTH value. Now I find my RTH value. Okay, so this is the RTH value which I found. So this RTH value is found. Now I only remain with the ISC value to be found. So let's find the ISC value, and to find the ISC value, that is short circuit current value, uh, we will use our mesh analysis technique or a nodal analysis technique to find the current through this branch AB. So I need to find my current, that is ISC. So this is my ISC current, that is short circuit current between A and B. Okay, and to find this short circuit current, I will use mesh analysis. Okay, so I will use my mesh analysis to find this short circuit current. But before finding this, to simplify my network over here, okay, so to simplify my network, the first thing I will do, I will merge this current source in this branch over here. So I will merge this current source in this branch by using source transformation technique. Okay, so what source transformation technique says, that the any current source or a voltage source can be transfer. Okay, so the current source can be converted into a voltage source, or a voltage source can be converted into a current source using resistance. Okay, because this all comes from the Ohm's law. So from Ohm's law, I know to find the voltage I just require the value of current and resistance, which I have already. I have a current value over here and the resistance value over here. Okay, remember that my branch resistance will not change. I am just going to transfer convert this current source in a voltage source. Okay, so my V voltage will become the branch voltage will become current, that is 4 into 6, which is going to 24, 6 fours are 24 volt. So my voltage of this branch will become 24, and my branch will look like this: the voltage source and the resistance. Okay, so this is my voltage, that is 24 volt, and this is my resistance, that is 6 ohms, which is same over here. Okay, so I will replace this branch by this branch. Okay, and my circuit is going to look like this. So this is my circuit. Okay, I just replaced my branch. You can see over here, that is 24 volt voltage sources get added, and the what we say, the resistance remains same. Okay, so I will to find the ISC value, I will just use a mesh analysis technique. Okay, so to write the first equation of loop is in this way, that is 20 volt. Always write first value of voltage source, start from the voltage source. So 20 volts is equals to 15 resistance, 15 into current value, that is I1, plus 10 resistance, and the difference of this I1 and I2, that is I1 minus I2. Okay, so this is my first equation, and by solving this equation I will get 25 I1 minus 10 I2, which is equals to 20. Okay, so this is my first equation. Okay, to find the second equation, I will apply mesh analysis on the second loop, that is this loop. Okay, so I will start from my voltage source, that is 24. So 24 equals to 6 I2 plus 4, that is this 4 I2 plus 10 I2 minus I1. So this is my you can say this is my next equation, and by simplifying this equation I will get uh, that is minus 10 I1 plus 20 I2, and that is equals to 24. So this is my second equation. Okay, so solving my first equation over here, my first equation and my second equation simultaneously. Okay, so solving these two equations simultaneously, I will get the value of I2. Remember, I need to find the value of I2. Finding the value of I1 is waste of time, because you can see in this diagram what is my ISC. My ISC is just the value of I2. So this is my current I2. Okay, and this is my current I1. So I need to find the value of I2. My I2 value will give me my desired value of finding ISC. Okay, so you just uh, solving these two equation, finally I will get the value of I2, that is I2 equals to 2 ampere, and this is nothing but my ISC value, that is ISC is equals to 2 amperes. So this is my ISC value. Now I find my total resistance and total and the short circuit current, and my circuit, the final circuit, that is Norton equivalent circuit, will look like this. So this is my Norton equivalent circuit. You can see here I found my ISC value and my RTH value, okay, of this circuit which is given to us. So this is given to us, and we found, and we convert this circuit in a Norton equivalent circuit of this. Thank you.